So we are learning statistics and quantitative techniques, and this is unit 13, game theory. So what is basically a game theory? It is a mathematical tool we used to study the situation called the game. So what is a game basically? So you have two or more parties involved, and they have some common interest, and they sometimes they have means conflicting interest, and they come together and do something, or their actions are completely opposite to each other. So it depends on situation what type of game it is, and you're studying that game and you're coming up with the solution. You're trying to find out the value for that game. Okay, so this is a game theory. So example is, let's say two competing firms are there, and they are fighting with each other or competing with each other for market share. So when they want to gain the maximum market share, what they will follow the different strategies, right? So in game theory you have different strategies. So strategies are the actions, course of actions selected by the players. Who are the players basically? Any two parties who are involved in that particular game are the players of that game theory. So the players can be people, they can be the organization, they can be the countries, anything. Okay, so the two parties in two or more parties. So we are generally in this unit, what we are learning is about two parties zero sum game. We are learning about two parties zero sum game, but not just two parties. They can be more than two parties. So we are not going in detail for the multi-party. So multiple parties, when multiple parties are involved. So in your book only, the whatever explained under the game theory is two parties zero sum game. Okay, so we are learning two parties zero sum game, where the two parties are involved in that particular game, and they have, let's say, the common interest. Like here, the two firms are competing with each other for the market share, you can say. So they may follow the same strategy or different strategy. They might follow the same strategy and they might follow this different strategy. So accordingly, your game will change. Okay, so these are the different terminologies we have in game theory. The players are the two parties involved. Then strategies are the courses of action they may take to lead to outcome. So here, if having the maximum market share is the outcome, so what type of different actions they might take? So they might go for aggressive marketing. They might go for the free sampling. They might reduce the cost of their particular product to get the market share. So initially they might face the loss, but their objective is, or the goal is, to get the market share. Once they get the maximum market share, they might increase the price of their product, or some discounting they can give on their product. So these are the different strategies, like different courses of actions they can take. So these are the strategies. Then the rational choice. So what is the rational choice? The rational choice is the strategies are analyzed in game theory, and players, sorry. And the players select strategies to obtain the preferred outcome. So they have to choose, once they select the different strategies, they have to choose one strategy among all of the strategy, or they can make a mix. They can select multiple strategies at a time, right? So sometimes they go for selection of this as a single strategy. They may follow the single strategy to get their goal. Sometimes they follow the multiple strategies, the combination of the strategies. So if they have limited fund to, let's say, to get the market share, so 60% of their fund they may be invest in reducing price strategy. This 40% may be in the aggressive marketing, 10% may be on discounting, anything can be there. So when they were using the mixture of different strategies, that time we are saying mixed strategies are used. When they are using the single strategy, that time we say the pure sum, pure strategy is used. Okay. So two-person game of the total conflict. So let's say here we have the two players, player A and player B. So why this is max and mean is written, I will explain you. So let's say this is the game theory matrix, you can say. Okay, so here you have the strategies b1, b2, b3, a1, a2. So strategies can be same for both the players, can be different for the both the players. Okay, so here the strategies are different for both the players. The B is selecting has selected strategies b1, b2, b3, and player A is coming up with the strategies A1 and A2. Okay. So, and what these are the actual payoffs. A11, A12, A13, A21, A22, A23. These are actually the numbers. Okay. These are the numbers. So we call them as a payoff. So two-person game of total conflict. What's meaning of this game in which one player wins, the other player loses. So actually, here you have the numbers. Okay, let me write here. Here you have the numbers like this is the player B, this is the player A. These are the strategies B1, B2, B3, A1, A2. They can be same, they can be different. Okay, so here actually you have the numbers. Let's say here the number is 20, 30, minus 40, minus 10. Let's say here the number is 35, 22. So these are the payoffs. So what is the meaning of this? The two-sum game of total conflict means whatever the matrix is written is according to the player A. The player A. Okay. So the 20 is the gain for player A by using the strategy A1. At the same time, 20 is the loss if the B is choosing, means the matrix is written according to A. Okay, so if he is going with this A1 strategy, so B can come up with B1, B2, and B3, right? So they don't know what strategies they are following. Means A don't know what strategy B is following, B don't know what strategy A is following. If A chooses the strategy A, okay, so if B is coming up with B1 strategy, that time A is making profit. So ultimately the same amount is loss for B. Okay. So A is a profit for 20 is the profit for player A. The same amount will be the loss for player B. Okay. So when A is coming up with the strategy A1 and B is coming up with the strategy B1, that time A is making a profit of 20 and B is making a loss of 20. Okay. So how you interpret this number minus 10 when A is selecting strategy A1, he is making a loss of 10 and the same amount will be the profit for B. Okay, so when the negative number is there, that is a loss for A and profit for B. So when the positive number here is, this is a profit for A and same amount will be the loss for B. So this is how we read the payoff matrix. Okay, so here minus 40 is there. So what is meaning of this? When A selects the strategy A2, it will make a loss of 40 if B selects the strategy B2. Okay, so A is coming up with strategy A2, and if B selects the strategy B1, that time A is making profit of 30 and B is losing the 30. If when A comes up with the strategy A2 and B is with B2, but B2 is making a profit here. So they don't know basically. So this is how we can interpret the payoff matrix. Okay. So what is a pure strategy? A course of action player can choose in game that does not involve randomized choices. A player always chooses a particular strategy. So A is coming up with only one strategy, A1 or A2. So it is not combining multiple strategies. So such game we call as a pure strategy game. Okay. So when a player A can combine multiple strategies, that time we called it as a mixed strategy game. So he will follow both the strategies at the time. He is following both the strategies at the time, and this will be the difficult game to understand, right? What we are learning is for the pure strategy here in this unit. So payoff is the outcome of playing a game. So these are the outcomes of playing a game. Payoff matrix. So it is a rectangular array of numbers. In two-person game, the rows and columns correspond to the strategies of two players. So when A follows A1 strategy or A2 strategy, these are the outcomes. Or B is coming up with the B1, B2, B3 strategy. These are the outcomes. So here in game theory, we have a saddle point. So I think you have understood what the how the game theory matrix looks. Okay, so you have two players, player A, player B. You are writing their respective strategies, and the payoffs are given. So you are finding out the saddle point. So what is a saddle point? Saddle point is a result when max min is equal to minimax. So what is max min and what is min max? We'll see this in this slide. Okay, so saddle point, just remember that the saddle point is point where your max min value is equal to or same as the minimax value. And it is the value of the game. When you have the saddle point, the value at the saddle point is the value of the game. So what is basically the value of the game? The value of the game is, you can say, is the value that A1 is guaranteed at least to win if B chooses any of the strategy. Minimum profit for A when B chooses any of the strategy is the value of the game. So when you have minimax is equal to max mean, that time we are saying that we have a saddle point and that value is the value of the game. The best outcome that both players can guarantee in two-person zero-sum game. Two-person game means two players are involved. And zero-sum game means the profit for one player, the same amount will be the loss for the second player. If there is a saddle point, there is a value. And that value, we are saying that the value is the value of the game. Otherwise, it is expected payoff resulting when players choose their optimum mix strategy. So when we don't have the saddle point, that time we can say that the players are not using the pure strategy, they are using the mixed strategy. When we have the saddle point in the game, we are saying that the players are using the single strategy. Otherwise, we are saying the or pure strategy. So when we don't have the saddle point in the game, we are saying the strategy used is a mixed strategy. So there are different types of games: two-person game, multi-person game. So here we are learning two-person game, zero-sum game, and non-zero-sum game. So non-zero-sum game means whatever the profit for A will exactly the same amount will not be the loss for B. The B might have the more loss or less loss or less profit. Anything is possible. Okay, so the values are not same, and that is a non-zero sum game. But here in this unit, what we are learning is two-person zero-sum game. Means in this unit, we are learning when just two parties are involved and the profit for one party is exact amount the loss for the another party. So when profit for one party is exact amount, the loss for another party, we say that the game is zero-sum game. So here we are learning two-person zero-sum game. So these are the strategies: maxi-min strategy and minimaxed strategy. So what is maxi-min strategy? In two-person zero-sum game, the pure strategy of the row player corresponds to maximum in payoff matrix. So row player. So who is the row player here? We use the max-min criteria for row player. Row player is player A. Let's say you have a game like A, B. So let's say this is your payoff matrix. So you are applying the max-min strategy. So max-min strategy, in max-min strategy, you apply for whom? The row player. Who is the row player? A. Okay. So you will apply the max-min strategy for A1 and A2, two strategies, A1 and A2. So what you're doing, you are first finding out the max-min. So the strategy is max-min. So as the name suggests, first you are finding the minimum of the row. So what is the minimum here? The minimum is 2. So I'm writing 2 here. What is the minimum here? The minimum is 3. So I'm writing 3 here. Then you're writing the maximum of the minimum. So your maximum is 3 here. You're writing the maximum of the minimum and your maximum is 3 for player A. So now go to the player B. So we are using the minimax strategy for column player. Column player, minimax strategy. Which strategy we are using? Minimax. So what we are doing, first we are finding out the maximum of the column and then we are finding out the minimum of the maximum of the column. So the maximum of the column is 7, 9. Here the maximum is 5, right? So then you are finding out the minimum of the maximum of the column. So your minimax is 5. Your maximum is not equal to min-max. So we don't have a saddle point in this game. Okay. So we don't have a saddle point in this game. So if your game is like this, you have A, you have B, and your values are now try to find out max mean and min max. So this is max mean. You're finding for A and min max. You're finding for the player B. So minimum of this is 2, minimum of this is 6. So this is your max mean, right? So what is your min max? Min max. So first you are finding out the maximum. Maximum of this row is 7. Maximum is 10. Maximum is 6. Minimum of the maximum here. So here your minimax is 6. Max mean is 6. So you can say for this particular game theory problem, you have max min is equal to min max and you can say the saddle point exists. So I think you are clear with how to find out the maximum and min-max. So maximum strategy we use for the row player and min-max strategy we use for the column player. So pure strategy means the player is choosing just single strategy.
And
yes. So pure strategy means player is selecting a single strategy. So when the player is selecting the single strategy, then only we have the saddle point in the problem. Okay, so here you can say in this particular problem, what is the strategy they have used? Can you say, tell me now which strategy they have used? So if these are your A1, A2, and this is your B1, B2, and B3. So value of the game is 6. Okay, so they have used the strategy when the value will be 6. When A1 chooses the A2 strategy, and when where the 6 is here, 6 is here, right? So when A1 chooses the strategy A2 and B chooses a single strategy B3, then the value of the game is 6. So mixed strategy. The players randomize over the set of available actions according to some probability distribution. So they decide in what proportion they are using different strategies, and that is a mixed strategy. So fair game, we have 3 games here. The fair game is the game in which the value of the game is 0. So what is meaning of the value of the game is 0? The player A has guaranteed to win the 0 amount or 0 profit when he chooses any of the strategy. So that is a fair game. Okay. So then we have the non-symmetrical game. So non-symmetrical game is means the two-person constant sum game in which the row players gains are different from the column player games. So what we are learning is zero sum game. What is meaning of this? When I write here A and B, and if these are the numbers, so whatever the profit for A is same amount the loss for B. That's why we are calling it as a zero sum game. So this is an example of zero sum game. So this is not the case in non-symmetrical game. So if 2 is, let's say by choosing the strategy A1, let's say if by choosing strategy A1, the A is making the profit of 2, that time B might make a loss of 1. B might earn the more profit than A. So anything can be possible. Okay. So the whatever the profit for A will not be the same as the loss for B. So we say that such games are the non-symmetrical games. So this is one of the example of the game theory. So we have already solved this for form A and form B. So for form A, which criteria you are using? For row player, we use max mean. For column player, we use min max. Max min. So ending is minimum. So you're choosing first a minimum. Okay. And then maximum of the minimum. Max min. So first you are choosing the maximum. And then you are choosing the minimum of the maximum. So you can say here the value of the game is 6. You can say, right, like here, minimax is equal to maximum. So saddle point exists. And if the saddle points exist, the value of the game is the value at the saddle point, it is 6. So what is meaning of this? Value of the game is 6. So what is meaning of this? Means A will have guaranteed at least win 6 irrespective of the strategy chosen by the firm B. So this is an example. You can check whether the saddle point exists or not. So for row, what we are doing, what we are finding max mean or min max. For row calculations, we are finding out the max mean. Okay. And for column, min max. So first find out the max mean. So how we find out minimum of this? And then maximum of the minimum. So this is your max mean. Max min is 3. Min max. Min max we find in the columns. Okay, so first we find out the maximum and then minimum of the maximum. So here the maximum and min max are different. Okay, so we can say no saddle point exists. So if you want to find out the game value of the game, here you have one formula. So let's say this is your a11, a12, this is your a21 and a22. Then we have the formula a11 into a22 minus a21 into a12. What we are doing, we are taking the cross multiplication. A11 into A22 minus A21 into A12 divided by summation of these two minus summation of these two. So how to do the calculations here? A11 is 3 into A22 is 1 minus A21 is 4 into A12 is 5 divided by 3 plus 1 minus 4 plus 5. So you can do the calculations here. 3 minus 20 divided by 4 minus 9. That is minus 17 divided by minus 5. That is 17 by 5. 17 by 5 is the value for this game. So this is about the game theory. So I'm sharing a link with you. Kindly go to the link and share your feedback. If you have any query, you can ask me now. Or I'm sharing my email ID when you do the study for this subject. And if you stuck somewhere, then you can mail me. I shall answer your queries on mail. Okay, so you can ask me if you have any query in this unit. Otherwise, I have already shared my email ID here with you. When you do the study and if you stuck somewhere, you can mail me. I can answer your query on mail. Okay, so the next and the last unit I'm starting now. And that is a decision theory. So decision theory is used to take a decision when we know the outcomes of our actions, when we don't know exactly the outcomes of our actions, or sometimes means we take a decision when under certainty, when we take a decision under uncertainty somewhere sometimes. So accordingly, we have to change the method of selection. So here you have different options in front of you. When you take any decision, you have different options in front of you. And you are using the qualitative data. Qualitative data is numerical data to take a decision here. In decision theory, you are using a numerical data to take a decision when you have the different options in front of you. The good decision is one that is based on logic, considering all available data and possible alternatives, and quantitative approach. Quantitative means numerical approach. So these are the 6 steps in decision making. First step is define your problem. You're defining your problem, what kind of problem you have in your hand. List all possible alternatives. Problem or like if you we see here the example of Thomson Lumber Company. So the problem for this company, they want to launch a new product, but they are not sure whether they launch a new product or not. So if they come up with the launching of the new product, that time they need a small plant or at least large plant. If they decide not to come up with the new product, that time there is no need of the plant at all, right? So they have three decisions, three alternatives in front of them, out of which they are choosing one. Okay. So you have the problem, you are listing the possible alternatives. Identify the possible outcomes or state of nature. So once you hear, like in this example, so this is an example of Thomson Lumber Company, and they want to come up with the new product. So for their production, they want to come up with a new shed, basically backyard storage shed. Okay, so if they are coming up with the new product, they need at least small plant or large new plant, or they decided not to come with the particular product that time, they don't need a plant at all. So these are the three alternatives in front of them. So they are finding out the all possible outcomes for this alternative. So what are the outcomes when they construct a large new plant and they start their production? So what is the guarantee that their product will get a good market? So whether the market will accept their product or not. So they are dividing each of the alternative on the basis of whether the market is favorable or not favorable. Okay, so when they construct a large new plant, if the market is favorable, what will be the outcome? When the market will not be favorable, that time what will be the outcome? If they go for the small plant, if the market is favorable, then how much profit they will make? If they are coming up with the small plant and if the market is not favorable for their product, how much loss they will make? No plant at all. If they don't come up with any plant, so they are not starting a new product at all. So what are the situations? If the market is favorable or not favorable, what will happen? They will choose the opportunity to make a profit. If the market remains favorable and they would have constructed these plants, that time they had a chance of making a profit. If they don't come up with the plant, that time they are losing their whatever the chance, you can say, of making a profit. So you have to consider the third alternative also. So this is how you are identifying the possible outcomes or the state of nature. Then you are finding actual the payoff or the profit for each of the combination alternatives. So you're actually finding out the payoff matrix. You're finding out the numerical matrix for each of the alternative. Then you're selecting one of the mathematical decision theory model and you're taking your decision. So your decision will change as per the different models you use. So it's up to you and means which model you're choosing decides what will be your outcome. Okay, so you are using that model and making your decision. So we are learning about this particular company. So this is a case where the company wants to launch new product. So they have three alternatives: construct a large new plant, a small plant, or no plant at all. So each of their outcome, they are considering whether the market remains favorable or not. So accordingly, they are identify the conditional values for the profit for large, small, and no plants. So accordingly, they are finding out the numbers, numerical values. Then they are selecting which model to use. They are using the model and taking a decision. So this is the payoff matrix calculated for this particular problem. So what this matrix is? This is the matrix for Thomson Lumber Company. When they have three alternatives, they can construct a large plant, they can construct a small plant, and they do nothing. They don't launch new product at all. Okay, so when the market remains favorable, that time if they choose the construction of the large plant, and if the market remains favorable, then only they are making a profit of $2 lakhs. $2 lakh. Okay, so if they construct a large plant and the market remains unfavorable for their product, that time they're facing a loss of $1,80,000. When they go for the construction of the small plant, and if the market remains favorable, that time they are making a profit of $1,00,000. And if the market remains unfavorable, that time they are losing $20,000. So the losses of 20,000. If they do nothing, that time they are whether the market remains favorable or unfavorable, they are not making any profit or loss. So this is the payoff matrix we have for this particular problem. Now, once the payoff matrix is in front of us, what we are doing, we are deciding which model to choose from the different decision theory models. So types of a decision-making environment. So now we are here up to the Thomson-Lombard company. So the next is the type of decision-making environment. So you have to take a decision under the certainty. So when you know the outcomes of your alternatives, there is no ambiguity in your mind what will be the outcome. You are very sure that the market will remain for you are just considering this part. You are very sure that the market will remain favorable for your product, and you are going for you have to take a decision among these three alternatives. If you are sure that market will remain the favorable, that time definitely you will go for the construction of the large plant. So you are taking a decision under certainty here. You're not considering this part unfavorable market. Okay, so you are sure about the outcome of your alternative. That time you are taking a decision under certainty. Okay, so this is very easy to take a decision when you know the certain outcome of your alternative. Your outcome of your alternative is certain thing, you know it, and accordingly you are taking a decision. So if you have to take a decision when the market remains favorable, you know the market is remaining favorable 100%, you are sure. So definitely you will go for the construction of the large plant, right? So it is easy to take a decision when you are taking a decisions under the certainty. Decision maker knows certainly the consequences of every alternative. Okay, so this is the type 1. The type 2 is decision making under uncertainty. So here, in this payoff matrix, you're not certain whether the market remains favorable or unfavorable. Okay, so you are taking a decision under uncertainty. And also, you don't know the probability or chance that the market remains favorable. You don't know the chance that market remains unfavorable. You know there is the possibility that the market will be the favorable or unfavorable, but you don't know the chance. What is the chance that market remains favorable? Is this the chance 50-50 or 80-20 means 0.8, 0.2, or the reverse is there 0.1, 0.9? So accordingly, you are taking a decision. So when you don't know the probability, whether your market is remaining favorable or unfavorable, that time we say we are taking a decision under uncertainty. You're taking a decision under uncertainty. Okay. So the next is you now in this matrix, you don't know the chance that the market remains favorable or market remains unfavorable. The more information is not given to you. What is the chance that the market remains favorable? What is the chance that market remains unfavorable? You don't know the probability. So in this problem, you are taking a decision under uncertainty. If they provide you the information that what is the chance that market remains favorable, what is the chance that market remains unfavorable, that time you are taking a decision under the risk. So you are accepting the risk. You know what is the chance of losing the money, still you are taking a risk. So you are making a decision under risk. Okay. So now we'll learn the different methodologies we have under the decision making under uncertainty, and then we learn the methodology under the risk. So you have different criteria here. These are the different methods you can use for taking a decision. Okay. So what are the different criteria? You have the 5 criteria under the decision making under uncertainty. So the alternative, each of your alternative have the multiple outcomes, but you don't know the probability of final outcome. You don't know the probability of the outcome. So what is the chance that market remains favorable, or what is the chance? You don't know that. That is the case when you are taking a decision under uncertainty. When you don't know the probability, you are taking a decision under uncertainty. When you know the probability and still you are taking a decision, so you are accepting a risk. So we call this as a taking decision under risk. So these are the different criteria we have for decision making under uncertainty. 1, 2, 3, 4, 5 criteria. We'll see them one by one. So max-min criteria we also call this as a optimistic criteria. The second criteria is max-min criteria. We also call this as a pessimistic criteria. Third one is criteria of realism. This is given by the scientist Hurwitz. And the fourth one is equally likely criteria given by the scientist Laplace. And the last one is minimax regret. So let's see them one by one. So max-min criteria. So the same thing as we have done in the decision theory, right? So game theory. So max-min, when you're using max-min, so first you are finding out the maximum of the row, maximum of the row. So what is the maximum here? 2 lakh, right? So what is the maximum here? 1 lakh. Then you are finding out the criteria is maximax. So you are maximum of the maximum. Maximum of the maximum is 2 lakh. So you're optimistic that you will make a maximum profit. And what is that? 2 lakh. So you are taking a decision accordingly. So you are ready to accept all the challenges for making this profit of 2 lakh. You don't know whether the market remains favorable or unfavorable, but still you're taking a decision by remaining optimistic that surely the market remains favorable and you will make a profit of maximum profit of 2 lakh. So this is the maximax criteria. The second one is maximin criteria. So first you are finding out the minimum, then you are finding out the maximum of the minimum. Okay. So here, if you see, this is a pessimistic. So you don't want to take any risk. You don't want to take any risk. You are not ready to bear any loss. So you are playing safely. So there is a chance that you will lose here $1,80,000. There is a chance that here you will lose $20,000. And only this is the alternative where surely you are not losing anything. So you will play safely. You will not invest in construction of the plant and you will not launch any of the new product. So this is the maximum criteria. Then this is the criteria of realism. So you don't know the probability that what is the chance that the market remain unfavorable, what is the chance that market remain favorable. So in this criteria of realism, what you are finding, you are selecting the coefficient of realism. You don't know the exact chance, but you realize that the market will remain favorable and you are deciding what is the percentage that the market is remain favorable. So let's say if this percent, I think 80% chance that market, no one is telling me that 80% chance there that market will remain. This is my assumption. Okay. So this is the coefficient of realism. You're realizing the value of the alpha. You are deciding the value of the alpha. And then you are finding out the weighted average. Okay. So alpha into maximum in the row and 1 minus alpha into minimum in the row. So 0.8 into maximum in the row is 2 lakh plus 0.2 into minimum of the row. Again, for this second row, 0.8 into 1 lakh plus 1 minus 0.8, that's 0.2 into minimum of the row is minus 20,000. So you are finding out the value of the realism here, and at the when you are choosing among the different alternatives, you're selecting the alternative with the maximum value of the realism. Then equally likely, this is or we call this as a Laplace criteria. Okay, so here also you have three alternatives and you are giving the equal, you are saying that there is 50-50 chance. Still you don't know the probability. So you are saying you are giving the equal chance to each alternative. Here we just have the two alternatives, so we'll give 50-50 chance. If you have three alternatives, you are giving 33.33, 30.3.33, 33.33% chance. Equal. So when you give the equal weightage for each of the alternative, ultimately you are finding out the arithmetic mean. Okay, so what you are doing, you are finding out the arithmetic mean in these alternatives because you are giving the equal chance. So 2 lakh plus minus 1,80,000, that is 20,000 divided by 2 is 10,000. So your row average is 10,000. 1 lakh minus 20,000, that is 1,20,000 divided by 2. Sorry, 80,000 divided by 2, that is a 40,000. So for third alternative, the value is 0. So you are finding out the maximum of these three, that is 40,000. So by this criteria, equally likely criteria, you are selecting the second alternative. Construct a small plant. So this one is the minimax regret. So you are finding out the opportunity loss matrix. You are finding out the opportunity loss matrix or regret matrix, and then you are using the regret matrix to take a decision. So what is the opportunity lost? So actually these are the alternatives, right? So when for the first alternative, when they go for the construction of the large plant, and if the market remains favorable, that time they are not losing any opportunity, they are making the maximum of the profit. So here the value is 2 lakh minus 2 lakh is 0 for this particular payoff. If they choose the second alternative and if the market remains favorable, so they are losing the chance of making the extra profit of 1 lakh, which they would have earned if they go for the selection of the first alternative, right? So the maximum profit they can make is 2 lakh, but they are because of the selection of the second alternative, they have lost the chance of making extra profit of 1 lakh. Okay, so here the opportunity lost is of 1 lakh. If they do nothing and if the market remains favorable, that time they are losing the chance of making 2 lakh, whole 2 lakh profit. So this is the value written here. So if they do nothing, this is a regret they have, opportunity loss. They have lost the opportunity to make a profit of 2 lakh. Now for this, when the market remains unfavorable, okay. So if the market remains unfavorable and that time they have chosen the first alternative, okay. So if the market remains unfavorable and if they would have chosen the third alternative, then only there is a chance that they are not losing anything, right? So here, if the market remains unfavorable, they have lost the chance, or the regret is they have lost the $1,80,000, right? So this is the opportunity they have lost. Means this is the loss they have made. They have lost this opportunity. So if they would have chosen the third alternative, then they have the chance of saving the loss of 20,000. So this is the lost, this is the chance they have lost of 20,000. So if they go for selection of the third alternative, and if the market remains unfavorable, they are not losing anything. So they are not losing anything. So they are not missing any opportunity. So this is the regret matrix we have. So once we have the regret matrix, we are finding out the minimax regret. So we are finding out the maximum of each of the row, and then we are finding out the minimum of the maximum. So maximum of the row is 1,80,000 here, the 1 lakh here, the 2 lakh, and then we are finding out the minimum of the maximum of the row. So these are the different criteria we have when we are taking a decision under uncertainty. When you know the probability of the outcome, that time you're taking a risk. So we call this as a decision making under the risk. So for this, we have the expected monetary value calculation. So what is the expected monetary value calculation? Payoff of the first state of the nature into probability of first state of the nature. So we know the probability. We know the probability that market remains favorable. We know the probability that market remaining unfavorable. And accordingly, we are doing the calculations and we are finding out the values here. Okay, so in this particular problem, each market has the probability of 50-50. So they're saying that probability that the market remains favorable is 50%, or chance is 0.5, and the market remains unfavorable is also 0.5. So which alternative would give you the highest EMV? So you have to do the calculations like first 0.5 into the first payoff in the matrix, 0.5 into 2 lakh plus 0.5 into 1,80,000, then 0.5 into 1 lakh into 0.5 into minus 20,000. So these are the calculations here. And here the 0.5 into 0, 0.5 into 0. So the answer is 0. So if these are the EMV values written here, so if you are using this criteria to take a decision under the risk, so you will suggest that go for the construction of the small plant. So here we are done with the unit 14, and this is the last unit from your whole syllabus. So I'm sharing a link with you. Kindly go to the link and share your feedback. Again, you can ask me if you have any doubts. So all your assignments, if you have any query in your assignment, then also you can ask me. If you're stuck, you have total 14 chapters in your whole syllabus, and we are done with, this is the chapter 14, the last one, decision theory. Now, different method, how many different variables, right? If there is independent variation, then we will be saying a method which can be called, which are applicable for one different variable. How do you do So if you have any query, I have already shared my email ID here. You can ask me on my email. I will answer you on email. Here we are done with our syllabus.